Hello everyone! In this video I'll explain how these climate control panels here, fitted to the Citroen Synergie, the Peugeot 806 and the Fiat Uylsse, I'm going to do a little bit of explaining as to how exactly these work. I know for a lot of you who are out there who own these vehicles now, these vehicles are getting a bit long in the tooth and there isn't really much information available on these climate control panels. So I'm going to bench test the unit, as you can see here, and we're going to talk you through exactly how to diagnose and correct potential faults. For the purposes of this video, this is the panel that I'm going to be doing the most of the testing and the diagnostics on. This is, as I said before, this is the full digital panel. This was fitted to a great number of vehicles. However, there were 3 panels available. This is, as I say, this is the most common one, and it's also the most expensive. I'm going to start now with the just show you. For example, there were 3 different panels, as I said before. You've got the full digital panel. The panel below this one was this panel. This has the slider controls, and it has manual buttons for the air recycler and air conditioning. The panel below this one, the most basic panel, still had the same slider controls, and it had a slider simply for the air recycler. That panel was fitted to vehicles without air conditioning, so that was the most basic panel. I don't unfortunately have one of these here to show you, but that was the most basic panel. It had a slider for the air recycler, and it didn't have air conditioning, that model. If your vehicle had air conditioning, it would either be fitted with a digital controller here, or this one that I have here. This one wasn't fitted to too many vehicles. I've only ever seen this fitted to vehicles between the years of 2001 and 2002. It might have been fitted to vehicles previously, I couldn't really tell you. As I said before, this is the panel that we're going to feature on in this video, simply because it's the most common one found on vehicles. The very first thing we need to understand with these digital panels is that these are entirely controlled by electronics. There is no mechanical systems at all that connect this to the heater and blower box. If we turn this around so we can see the rear portion of this thing, there is 2 great big multi-plug connectors on the back, and that is it. There is no mechanical linkages at all on this system. It is entirely electronics with stepper motors and servos and sensors. That's the very first thing we need to understand. Now I've got the whole wiring loom on the desk here. The wiring loom for the blower box and the fans and everything is entirely encased in its own loom. So it's entirely separate from the body loom, and it connects to the body with 3 connectors lower down on the side here. So I'm going to zoom the camera in on these 3 connectors. We can have a look at exactly how this climate control panel connects to the body of the vehicle. You'll have to excuse the free hand with the camera here, gents, but I shall film this as best as I possibly can. As I said before, there are 3 connectors that connect this loom here for the climate panel to the loom of the body, so the body loom of the vehicle. And there are 3 connector plugs that do that, depending on model, that is, depending on model. The main 2 connector plugs is this red one here with 2 very beefy, either 8 or 10 square mil cables on it, quite beefy. There's this black multi-pin connector plug with about 7 or 8 connector pins inside it, and there is this smaller white one here as well. Now the other climate control panels, if you don't have the full digital panel, the other climate control panels don't actually have this white connector. They purely have the red one and the black one. Also, if you have the very basic model without air conditioning, I don't think it has this extra wire here. I know it only has 1 fan, that car. All the other models that have air conditioning have 2 fans. Now I have to excuse these jumper wires here that I've put on. This is only so I can connect it to my desktop power supply unit, so we can actually bench test it. So excuse the little regulator rectifier box here that's powering this at the moment. That's how we're going to bench test it and prove how it works. Now I have on the computer, I've actually drawn a pinout for this connector, but I'm not going to leave this thing on the screen too long. What I'll do is I'll put the connector pin out at the end of the video, and for anybody who's interested, they can actually see the connector pinout at the end. So if you're looking for pinouts of connectors, I'll stick this as an image file right at the end of the video, so you can pause it and have a look. But I have worked out the pinout for this connector, and also if I scroll on in the images, there is also another image for the smaller white connector as well. So I'll leave those at the end of the video if you care. As I've previously mentioned, this unit is entirely controlled by stepper motors, and in the system there are 5 stepper motors in total that control the airflow and the air direction. We have 2 stepper motors in the driver's footwell, to the left hand side of the driver's footwell, 2 stepper motors that control the airflow and the direction. These 2 control the direction of the airflow. We have another stepper motor in the driver's footwell that controls the temperature, and that's 3 stepper motors, and we have 2 more stepper motors, one on each side, at the very sides of the vehicle, one here and another one on this side, and these 2 control the air recycler. So there is 5 in total. 2 control the air recycler, 2 control the air direction, and 1 controls the air temperature. Some of you out there may be wondering why we have 2 stepper motors for the air recyclers, because why do we need 2 when there's only 1 air recycler? And that is because these digital panels, as does the other panel with the manual air conditioning buttons you saw earlier, those vehicles, anything with air conditioning, has two intake fans. They have 2 fans either side of the car, one on the passenger side, one on the driver's side, both working in parallel, both doing the same jobs, bringing in the same fresh air or recycled air. There has 2 fans to help push the air through the cabin. Now, I have one of the fans here. We can have a look at exactly what makes the fan tick. They're not identical units on either side of the car. You'd think this fan might fit that side and this fan might fit that side. They are not identical units. The mounting points are the same. This is something to bear in mind when you are replacing fans, because I've actually replaced fans in vehicles before and put the wrong ones in the wrong side, and the fan fires up fine, it mechanically fits in but no air blows through. So be very careful when you're getting spare fans that you take a fan off the right hand side of the car and put one on the right side. A fan that comes off the left side must go back on the left side. They look identical, but if you actually look on the photographs, if you compare 2 of them, this is off the, let me get this right, this is off the driver's side of the car, the right hand side. If you compare these blades of a fan to one off the left hand side of the car, the blades will actually be pointing the other way. The impeller on this fan is actually different, so be very careful when you're ordering replacement fans if you ever have to do that. As I say, these will mechanically fit in, but they won't actually work, they won't actually blow the air and blow through. These fans themselves, as I say, there's 1 on either side of the car. Both of them blow the air around the back into the airbox and across the evaporator and then into the rest of the heating and ventilation system. These blower fans, these have a built-in resistor and variable speed drive on them. They're a little bit more fancy than your standard sort of blower fan, and I'll come on to that more in a minute, very shortly. These are actually a full variable speed fan. They actually have quite a lot of digital circuitry built into this base of the unit, which controls the speed of the motor. So I'm going to show you now exactly the most common fault that I find with vehicles is the fact that the air's not blowing through and the fan's stopped. Now what can sometimes happen is the scuttles block up, water pours in and ruins the fan unit. So I'm going to show you exactly how to test the fan unit on these, to test that these are working okay. So once you've grovelled into the footwell and pulled off a load of plastic trims, and you can actually see the base of the blower fan here, this is the driver's side, the passenger side is also identical. You'll come up against this, and this is the bottom of the fan unit, and you will see 2 very beefy wires, one red one green, one going into the fan unit, and also a small white one in the middle. Now, bearing in mind when I describe the testing procedures here, these tests are always done with the engine running, because the climate control panel doesn't actually work with the engine off. Now with the engine running, and we're going to get our multimeter here on the up to 20 volt range. What we should do, if we put one of the leads of the meter onto the earth, the negative lead of the meter, we want to test between the live pin here, this big red one, and we want to test between that and earth. Now it's not going to work here because I haven't actually rigged up the entire wiring loom, but we should get, if we put this on here, we should get 12 volts at all times, no matter when the engine's running, no matter whether this climate control panel is on or off, no matter what is going on here, no matter what's going on here, whether this is off, whether this is on, doesn't matter what. Whatever's happening on here is irrelevant. With the engine running, we should always get 12 volts on here, or when the engine's running, of course, it will be a little bit more, it'll be about 13, 14 volts with the alternator running and charging the system. We should always get that here. Again, earth here, you could put the tester simply across here if you wanted to. That is also a way of doing it. You can put the tester straight across there. You should get your full 12, 14 volts across here at all times with the engine running. This white wire here in the middle This is what communicates between the blower controller actually inside this unit and the control panel itself that the driver interfaces with. So again, I've actually cut the earth off here. As you can see, this would attach to the bodywork just on the inside of the wing, but I've actually cut this off the vehicle that it came from. So what I'm going to do, I'm just going to cheat and stick the probe of my meter on the earth that I've rigged up here. So the other side of the meter here is actually earth at the moment. And I'm going to get my climate panel, I'm going to switch it on, and I'm going to put it on the lowest speed possible. And I'm going to stick the live probe of the meter into the white terminal here. So effectively the other terminal of the meter, the common lead, is actually going to ground at the moment, so we're measuring between earth and the white pin inside here. And again, I'm on the slowest speed setting on the climate panel, and we can see we've just got about 1 volt on the multimeter here. And you can guess what's going to happen as I increase the speed here. Watch what happens to the meter as I increase the speed. If I increase to the second speed, we jump to 1.34 volts. Third speed, 1.68 volts. Fourth speed, 2 volts. Fifth speed, 2.5 volts. Sixth speed is 3.18 volts. And the full Hurricane 7 speed is 4.61 volts. So what this climate panel is doing is actually a digital to analog converter. Effectively, I'm giving it the set speed here, and it's turning it into an analog voltage, which it applies to the to this driver wire inside of the blower controller. So in theory, you could actually have a mechanical rotary knob here. You could have infinitely variable speed. It's only the fact that the idiots at Citroen decided to actually limit it to 7 speeds and put the controller on here. So again, if you're wanting to test that this panel is working alright and the signal is getting up to here, on full speed we should have about 4.6 volts to that pin, and it should go down as you reduce the speed on the panel here. This is exactly the same for all the vehicles, no matter what climate control panel you have, whether you have a slider control, whether you have this one, you should still get the same results between the earth and this pin here, the white wire, the driver wire. We should get the same result. On the lowest speed it should be about 1 volt or 0 if it's off, and on full speed we should get about 4.6 volts to the driver board here. Again, the only reason why this fan isn't spinning at the moment is because the live ends of this cable are not actually hooked up at the moment. The live ends both go to here, and they're not actually hooked up at all, so that's why the fan isn't spinning and flying off the desk. Now this digital panel is actually quite intelligent. This can communicate with the dealer diagnostic software. There is a wire running from here to the diagnostics port so that fault codes can be read off it if necessary. But this unit actually has its own indication that something is wrong. Now I've simulated a engine switch off at the moment with the power switched off on my bench testing rig here. And watch what happens to the decimal point when I power the unit back up again. Watch the decimal point. It will flash twice when I switch the power on. 1, 2. You see that flash of the decimal point? That indicates that there's a fault with it when the unit starts up. So when you start your engine, and if you see this decimal point flash a couple of times, that will indicate that there is an error code stored on the unit. It's a bit of a sly way of Peugeot Citroen of doing it, because usually it would come up with, you know, E27 or E35 and an error code on here, but no, that's just a little small indication that something is wrong with the unit itself. Now I know what's wrong with this unit is because one of the temperature sensors in the cabin, of course, isn't connected up with me having only half the wiring loom on the desk. That's just a little indication that something is wrong if that decimal point light flashes when you start the unit up. There is another temperature sensor located on the front just above the glove box, which comprises of this little black unit. Now this little black unit has 4 wires going to it. 2 wires go to a DC fan on the back, and the other 2 wires go to a little temperature probe on the front. And what this does, this pulls a very small amount of air in from the cabin, passes it over the temperature probe, and this reads the temperature of the air in the cabin. Again, this is only fitted to the digital panels like this one. There is also 2 more sensors attached, and these connect to these. The rest of these are actually located on the vehicle loom, should I say, and it connects via these 2 interface plugs that connect the climate control loom to the vehicle loom. One of these sensors is located right on the very front of the vehicle, but below the windscreen where the immobiliser light is. That I'm assuming that reads the temperature at the top of the top end of the cabin, and it also is tapped off on this connector plug, the black one. As I say, the pinouts of this connector are at the end of the video. It connects to the external temperature sensor on the wing mirror, so it also knows, this unit itself actually knows what the air temperature is outside of the cabin. I'm not sure why it needs to know that, but on the other hand it does. So that's another thing that can potentially go wrong. It's also worth me saying that the blower fans on either side of the unit, this is the passenger side. Again, I showed you how to test the fan units before. It's exactly the same on the driver's side. I'll just show you here. There's the driver's side, there's the passenger side. It's exactly the same procedure to test it. You should get the same voltage on this white wire this side as you do on this side. There should be the same 12 volts on both of these here, and these both green wires should also both be connected to ground. So the testing procedure for the fans is actually really quite easy. There's nothing much to the testing procedure of the fans themselves. Before I move on to talk about the other climate control panel, the smaller, the non-digital panel, I'm just going to measure the DC resistances of the sensors, just to give you an idea if you need to bench test them and see what they are. I know both of these sensors work perfectly fine. I'm looking at the thermometer here, and it's bang on 21 degrees in the bedroom, and I've got the evaporator temperature sensor here, and I'm just going to bang the meter across the terminals, and we're just going to measure the basic DC resistance. So we can see we're at about 2.5 kiloohms at 21 degrees. Again, if I heat this up with my breath, it should change. You should see the resistance change. The resistance going down as I heat it up. So that just gives you an indication that the temperature sensor is working fine. But again, 21 degrees, you're expecting to find about 2.5 kiloohms. That's for the evaporator temperature sensor. I'm going to get the heater matrix temperature sensor here now, and we're going to do exactly the same thing. I'm going to pop the meter across the terminals, and we're going to measure the basic DC resistance of this as well. Let's see what this is measuring. He says. So about 11 kiloohms, 11.5 kiloohms at 21 degrees. If I blow on this again, we'll heat it up and we'll see if the resistance changes. See the resistance falling? That's falling quite quick actually, I'm impressed. Look at that. If I cool it down again with my blowing on it, the resistance climbs back up again. So yeah, we can quite easily test the temperature sensors that they're working alright. Before I move on to the manual climate control panel and do away with this digital one, I just thought it's worth me mentioning the pinouts on the connector plug here. I will put a photograph at the end of this video as to what exactly each of the pinouts mean. If you excuse me here, I'll read these things off to you now, and I'll just talk through exactly what they are, just so that you get a better idea as to what's going on. These connector plugs, by the way, these that connect to the vehicle loom, these are located just inside the passenger footwell. If you remove this panel, imagine this panel's here, these connector plugs are located about here, sort of 3 or 4 inches down the side of where the passenger's feet are. So they can be accessed just about with removing the panel, but it's not an easy thing. You're best off removing the footwell and dismantling a whole load of stuff to get to them. So I'm viewing them with the notch and the clip face down, so I'm just going to point to them with the sensors and just tell you exactly what they're going to do. I'll start with this one here. This one is the continuous live for memory only, so all this one's doing is for running the memory of the unit, so it remembers what temperature you're on. This one here and this one here, these two, that one and that one, these run to the external temperature sensor on the door mirror. So they are a blue and purple wire, I think they connect to on the loom, that one and that one. The one in between them on the right, this thicker one, this is a ground, an earth, negative, whatever you want to call it. That's the earth for the unit. Now moving across the top, This smaller one next to the continuous live, the end one as I said is the continuous live. This smaller one here, this one connects to a yellow wire which connects to the diagnostics port. I've forgotten what pin, I did trace it out once but I've forgotten what pin it was. That goes directly to the diagnostics connector for diagnostics. This one isn't on the, this is depending on model again, that one's not fitted to the non-digital panels. The same with these external temperature ones, these aren't fitted to the digital panels at all. The one in the middle, if I move these out of the way, the one in the middle at the top, this is the switched live and it comes from a blue relay under the bonnet. This is only energised when the engine is running, and the thing that causes the relay to click in is when the alternator spins up to speed, and that closes the relay in somehow with the sensor wire on the alternator. I'm not sure exactly how it does it, but this only comes live with the engine on. As I say, this is the thicker wire, so this takes the bulk of the current to run the to actually run the climate panel. Not the blowers, of course. The blowers have got their own supply through this this big connector block here. This runs the stepper motors. This also runs the supply to the air conditioning. This one, there's 4 wires over here now that we're down to. This one is a lighting live, so when you put your side lights on, this one comes live, and this tells the panel to dip the lighting so that you're not blinded by it at night. So again, that's your lighting feed. This one here, as I said before, these two go to the external temperature sensor, so that's those two covered, this one and this one, with the ground being in the middle. And these two end ones here run the air conditioning. Now this is where it gets a tiny bit complicated. We've got this thicker wire on the top, and we've got this thinner wire underneath. This thicker wire goes to the AC pressure switch under the bonnet and ultimately ends up through the relays and going to the air conditioning compressor. This is the post-defrost live, so what's happening is this unit, this temperature sensor that I'm holding in my hand, tells the unit what temperature the evaporator is at, and this switches this on and off if the the compressor off, sorry, if the evaporator frosts up and gets too cold, and it waits for it to defrost. However, this one underneath for the air conditioning, this one remains on. This is a pre-defrost live, so what happens is when the driver selects the air conditioning to be on, or doesn't in this case, it doesn't have an air conditioning button, it's got an air conditioning off button, we won't get onto that because it's stupid. When the air conditioning is demanded by the unit, both of these come live, and when this switches off the air conditioning because the evaporator's got too cold, this one remains live and this one doesn't. I'm not too sure why they put this one on that remains live. This one remains live whenever there's a demand for air conditioning and that it's defrosting. So even if it's defrosting, this one remains live. I'm not sure why it remains live, but it does. I think potentially I did trace it to the bulkhead connector on an XUD vehicle, and I'm wondering whether it's something to do with later models or models that had the common rail fuel injection, whether it went to the engine ECU to tell the engine computer to do something. I'm not too sure. As I say, on the XUD vehicles, this one isn't really needed. It's this one that actually goes through the bulkhead and ultimately brings the air conditioning on and off. As I said before, I'll just sum that up. This one is the post-defrost, so this one will switch on and off as the unit defrosts. This one doesn't, providing there's a demand from the driver for the air conditioning. This one will always remain on. As I say, this one's not always needed, but if you forgot all that, what I'll do, as I said before, I'll put a photograph of this at the end of the video where you can read the pinouts off. Before I leave you to go and shout and swear as to why you still can't find your climate control panel working, big roars of laughter, I just thought I'd mention this this panel with the manual buttons for aircon and air recycler. This one is a much better panel in my opinion because it doesn't do stupid things that you don't expect it to. But a lot of the principles are still the same. We still have the 0 to 4.5 volt regulator on here, so that should be 0 volts. That should be about 4.5 volts on the driver wire. If I show you from this side again, it's a different colour wire on this one. We've got a small wire, a green wire going to the middle, but again it's the same principle. You should have 12 volts on here, nothing on there when the engine running, and you should have this wire should vary in voltage as to what the panel is doing down here. This one also has a manual, this does have a cable on the thing. You can see the cable on the back here. This cable controls the airflow direction. This is cable controlled. You can see the cable moving on the end there as I slide the controller back and forth. So that in itself, that does away with 2 of the stepper motors. We're down to 1 stepper motor in the driver's footwell now. This controls the temperature. The temperature is still stepper motor controlled, and there are still 2 stepper motors, 1 on each side, that do the air recycler. I have worth mentioning, I have had quite a bit of trouble with air recyclers in the past, with them jamming on, and I'm not too sure why they do it, but I have had to disconnect air recyclers in the past because they seem to stick on. And of course people then wonder why their cars are all steaming up all the time, and I've looked under the in the front grills and found the air recycler flaps jammed completely closed, and I'm not sure why. If I get to the bottom of it, I'll post another video and let you know. So that pretty much sums it up for this panel. There is it's the same setup down the you have the same connector blocks down the side of the passenger footwell here. Again, same live feeds into here. There's no earths in these panels at all. There's just 2 live feeds, one to either fan. And again, on this one, as you can see, there's no connections to the white one because it doesn't have the sensors on the front of the vehicle. And again, there's no connection to the external temperature sensor on this one. It doesn't need to know the external temperature to work, does this panel. The one thing that I will say about this panel is the air conditioning works slightly differently. This panel has a separate defrost relay for the air conditioning, and if I move the camera I shall show you that in just a second. These are the 3 components that can be found inside the left hand side of the driver's footwell. We have the stepper motor that controls the air temperature. We have the evaporator temperature sensor, just like on the digital panel, but we also have the addition of this little relay unit. And this little relay unit is the defrost relay for the air conditioning. This is more than just a simple mechanical relay. This actually has quite a good bit of circuitry inside it. And I have in my very late in the workshop last night, I actually traced the pinout for this connector. So we have the air conditioning defrost relay here. All this does is switch off the air conditioning when the evaporator gets too cold. On the digital panel, this was actually done inside the digital controller itself. On this mechanical panel with the manual buttons for it, this relay does the defrost. Now, staring at the connector like this, with the grooves on the bottom, so we're looking at it like that. I'm going to point to it with this. There's 6 connections. These 2 are the power connections. We've got a ground at the top here. And we've got a positive at the bottom, which is not continuous. This goes off when the engine goes off. The 2 ones here, the one in the centre at the top and this bottom corner one, these 2 have the evaporator temperature sensor across it. So effectively this black sensor here, I've belled these wires through. This temperature sensor goes straight across here. Again, it doesn't go to the control panel on this one, it goes to this little relay. These 2 here you should have your temperature your 5 point whatever it was. I think was it 5.5 k ohms or 2.5. I can't remember what it was I just measured it only 5 minutes ago. This temperature sensor should be wired across these 2 terminals here, which then leaves these other 2 terminals, the bottom middle one here and the very top right one. This very top right one is the AC demand, so this is when the driver presses the air conditioning button, the panel outputs the air conditioning, alive on the air conditioning, and it appears here. Now this tells the relay to close in for the air conditioning, so what it does is, if the evaporator temperature is okay, it then outputs alive on this one, which then heads off to that bulkhead connect, which then heads off to the multi-pin connector that connects to the body loom, and ultimately this switches on the air conditioning. So to just sum that up again, we've got a ground here, a non-continuous live here, this goes off with the ignition. These 2 have the temperature sensor wired across them, and this is the demand from the control panel, so when the air conditioning button is pressed, this becomes live, and if all is well in the relay and the evaporator temperature is okay and not too cold, the relay will close in. There's some circuitry inside here, we'll close the relay in, and this one will come live and feed back onto the multi-pin connector. Now I'm going to bring this multi-pin connector plug into view, and we'll just wrap up on this multi-pin connector because it's worth noting this. I said on the I'll also put this schematic on the video at the end so you can have a look. If I scroll back, just escape that here. If I bring back up the photograph of the pinout of this connector, I'll just zoom in a bit so we can see the air conditioning. Again, we're going to go back to the black connector for a moment, and I'm going to show you this side of it. We've got the for the air conditioning, we've got the post defrost wire, which is this one, and the pre-defrost wire, which is this one. Now it's interesting how they've wired it on this panel, because what happens is, as I said before, when the driver presses the air conditioning button, one of these blue wires becomes live from the control panel, feeds down onto this connector pin here, feeds back up into the wiring loom and appears on this one here. So effectively these two wires, one of them comes from the panel, it feeds down to here, to this multi-pin connector, back up and back into this relay here. So that's how the pre-defrost feed hits here. Again, I don't know why they put a pre-defrost feed on it, because the main thing that's going to be used is this one, the post-defrost. Of course, this is what's actually going to bring the AC on and off. And again, the output from here, from the relay, this bottom middle one, goes back down the wiring loom and appears just as a single wire on this connector plug here. So I know it's been a bit of a rush thing to get through, guys, but I thought I'd let you know. And if you know anything else that I know that I don't, or have anything else to say, then please feel free to comment. So yeah, keep it warm and keep it cool.